The video that I am about to share with you today is primarily geared to those with a little bit of basic Python knowledge, including myself. Now, what we're doing here is we're combining two data sets. We're looking at the full year of basically 2021, right here, of all of vaccine adverse event reports from 2021, as well as all the vaccine adverse event reports, right here, get that, from 2020. And then what we are doing is we are combining all the vaccine adverse event reports to basically the COVID-19 vaccination trends in the United States. This what we have here is we have a great combination between basically three data files. The data files being as such the VAERS data, the VAERS symptom data, the VAERS vaccine data, and as well as the COVID-19 vaccination trends themselves, combined into one data frame. And what we are going to also do as well is we're going to eliminate all superfluous information that's not required. And I'm going to give you the code on how I did it. Now, keep in mind, I am very basic. I am an amateur when it comes to data science itself. And data science is an art, in which case I'm up to the point of drawing stick figures. You'll see what I mean in a second. But still, just the same, this is what we're going to do. We're combining four files. And the reason for this is because we can practice our skills on the vaccine adverse event reports as well as gain additional knowledge into regard to how atrocious the CDC vaccine adverse report system actually is, and how difficult it is to actually extract accurate data. So let me give you an example of what we did first. But first, let me show you, take that back. First, let's run the kernel in regard to the Python data and show you how it looks like after we get everything done. All right, so I have it in GitHub as well. You see right here, and that's the GitHub file. I've linked to that as well too. But let's go to basically the VAERS Vax data set right here. And we are going to take this kernel and we are going to restart this kernel and run all cells. Ready? Let me move this over here too, just because we know we need to get this out of the way. There it is. Go. All right, so what we have here is we're running the kernel, and what you got to do, what you have to do, preferably in order to get this to work appropriately, is you're going to have to download these data sets from the respective websites themselves. Put them in a respective file, and then you know what to do from there. If you've been using Python, for example, Jupyter Notebooks, which most of us have. So as we run as we run our file, you see all the information in regard to the columns. For example, that's the vaccine trend one. We're going to isolate that down to something a lot similar. All we're going to really use from the vaccine trends is three columns. We are going to actually four columns. Take that back. We're going to use the date, the administered daily, the administered cumulative, and administered 7-day rolling average. And we merge that with the vaccine adverse reports from 2021 to 2022. It gives you the ability to basically extract signals a lot more effectively. And signals being, for those not familiar, vaccine reactions and or trends. And so as we ran our kernel, we went all down and we merged the files. And if you want to see exactly how I did these things, is if we take, let's say, go to GitHub, you can see contain the year's isolated rows, drop rows, masks created for date ranges, so on and so forth, isolated columns, took the median of the number of days as well as found time delta in regard to fixing missing dates. So we fixed the missing days by filling in with the median, and then we fixed the missing dates by usually going to the onset date and subtracting the number of days, i.e. a pandas time delta, and so on and so forth. Merge the rows, so forth and so forth, and you can read all that and put it into a CSV file for your convenience. I normally would have taken the CSV file and uploaded it to GitHub or clinicalnews.org, my other site, but however though, the files were so large, obviously only got 25 megabytes on GitHub. So let's proceed forward. And there we are. And as we go down, this is what we're looking at. So we go through, we did all the data, and you review the code. It'll all be there for you, so there's no sense rehashing it now. And you can tear it all apart, do something better in a better way. I'd take no insult to that. I love to learn. So proceed forward. Basically, we looked at all the columns they had, for example, for those that don't recognize, and I will reiterate, the CDC's vaccine adverse event reporting systems is a literal mess. It is so tough to extract adequate data, and you'll see a lot of people on both sides of the spectrum who will misquote number of uh, deaths or mortality or side effects on both sides, because they're not taking into account duplicates. Let's show you what I mean by duplicate. All right, so as we go down here, this is, if you look right here, I'm just pointing at it so you can actually see. Point to note, the vaccine dose series value counts. They wanted to make it into a categorical, and so for those that use Seaborn and things like that for graphing. And if you could see, there's a lot of unknown, but a lot of people, for example, by 2022, December 30th, they already had over 7 shots. So keep that in mind. So if you're looking right here at the thing, that's what we're looking at there. Converting D types, so on and so forth, blah, 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 down the line. First, we want to validate we did this right and left out know what's called not numbered. So a lot of the NANs, you'll find out exactly how I filled it in. And just for example, let's go down here. And so first, let me show you those not familiar. Let's use the duplicated form of the data frame. And duplicate, for those not familiar as well, is this is how it appears. When we finish up and clean everything up and use pertinent data for your data extraction in regard to any sort of data science models, if you want to check out cumulative density functions, if you want to bootstrap stuff, it's great for learning on. If you want to learn on, for those data scientists, you want to learn on the Titanic, the sepal petal length, for those you know what I mean, or how many different animals Darwin observed, then go for it. But this is a lot more exciting way to do it. And so, for example, this is the column we merged with the vaccine adverse event reports with actually the COVID trends over those years. If you notice, for example, the total down there, so on and so forth. And it's interesting too. If you look at this right here, give this an example. Look what's happened towards the end as you look towards these dates. What correlation can you derive as far as one of the primary reasons a lot of data is being reported as an adverse event? And you see this here, you see where it gets confusing. And by the way, too, we also made sure we isolated the whole VAERS data set to only the COVID-19 vaccines. All right, so if you look right here, what do you see towards the end? A lot of people get administered expired product. It's just an observation. It has to be validated, but here we are. All right, so let's look at some validation tricks we can utilize too. All right, so we take VHD, let's do right there, and I'll leave this up so you can see it. Let's just copy that because I'm lazy. There's that, and then boom, we're going to take the data frame again, and there's that. And what I'm going to do is first validate. We want to look at basically our data types. All right, and look, I have this new keyboard and I can't find there's that. Doing comma. All right, here we go. So here's our data types. And let me show you a trick, because if you're doing CSV files, often what will happen is these data types will get erased. So let's say, for example, this happens, just to give you an idea. This is a neat little trick. All right, as type, oops, let's make it object. So you lose everything. You lose all the oops. Yeah, less anticlimactic. So you lose everything. You lose all the data. Boom. So all your data types go away, or your categorical data and everything else like that, your date frame, the whole lineup. You want to see a little trick your instructors will never show you? Here it goes. Ready? This saves you so much time. So here we are. It's totally shot. And so here we go. And I had to learn this on my own. Convert D types. And put nothing in. Just call it. And then at the same time too, let's go info again. So we get the data types. Watch this. Datetime, integer, string, categorical. That is really a super cool trick. All right, now, also too, as far as the data itself, let's go back to that. And now I show you why the duplicates in how this data frame, why it's important. Is NA. What we're doing first is validating the data. And is NA sum. Real important there, because we're looking for not a numbers which can interfere with our data extraction. And so here we go. Zeros. That's really kind of what you want to see. And that's how I cleaned up the data, so to say. All right, now let me show you the error that's often made through basically individuals which are not quite experienced in data science. So let's use a frequent example. Let's take this VAERS ID right there. And people don't realize, you see all these reactions. See that? You see 1,286,323, or reactions there out of 23 columns. For those that are more stringent on, let's do it this way. Oops. And of course, new keyboard. Oh, that sucks. New keyboard. All right, and so, oh, no, I forgot. That really sucks. Shape. All right, so you have right there 1,286,323 rows. Now, what people do is they'll go, oh my gosh, that's 1,286,323 vaccine adverse event reports submitted to the system. No, a lot of those are duplicated, and that's what I'm about to show you. So we go VAERS ID. All right. And then we go value counts. All right, so here we go. Now look right there. There's an ID right there that has over 80 duplications. 80 duplications. So we go, well, what the heck could be going on with that? So let's see. And remember too, so let's look at it. And let's just because things go faster with background music. All right, and there we have it. There and there. And let's really be super lazy. There. So what we're doing, for those not familiar, we're extracting VAERS ID report 2396371 that's repeated over 80 times. And often what will end up happening is they'll run out of room to list all the symptoms or tests they're doing in one report. So mistakenly what they'll do, which they should improve the database to where you can actually have enough room to put all the information on one report as opposed to having to put it on 5 reports and therefore being miscounted 5 times. So what they're doing, for example, is this is one individual. You see right here, age 54. Where they filed 80 separate vaccine adverse event reports. And you notice a lot of anomalies, like what the heck's going on here? Vaxo Series 1, Vaxo Series 2, Vaxo Series 3. Is he filing a report? Obviously not. So what this person is probably doing is they're seeing the Vaxo series, and they're probably trying to report that as a page number. But if you look at it, let me move me real fast. It's all the same number of days. So chances are the person didn't have 80 separate vaccines that day. And therefore that creates the issue. And that's why the duplicates are real important when trying to give a numerical assessment especially in regard to some sort of cumulative density function, how many times you get shot, what's the odds of a reaction, so on and so forth, from occurring. You have to eliminate those duplicates. And so if we take, for example, let's see, VX no dupe, and we look at it, let's be really lazy. All right, there's that. VX no dupe. And if you look at it, it's only 892,140 vaccine averts people that were reported to the system. Now, keep in mind, statistically, until otherwise noted, only about 1% of the reactions actually get reported to the VAERS systems. So it can be much greater, it can be not. That's where your bootstrapping is going to come in. So you see exactly what's going on there. So that's it as we extract it. So your value counts, you use your is_na.sum to make sure everything's there. You do your data types or D types or problem occurs or whatever it comes down to be. And then that will do is that will enable you to look at your symptom text here. It'll basically give you the ability to get the signals straight. And for those not familiar with signals, once again, we're attempting to see basically if there's some sort of ailment or reaction that is becoming common and appearing. Also, too, you have to look at the confounding involved as well. A lot of medical professionals don't know what, in the beginning, it was basically there's no side effects whatsoever. As time proceeded forward, they discovered it was. Now, check this out, too. So here we have the vaccine with dupe. Now, look at the anomaly right here. Number of days. Now, some people get vaccine reactions on the first day, when they get the shot. But if you notice right here, you're seeing reaction days now come 230 days, 397 days, 405 days, just in the top five reports going back. So now you have people reporting a reaction to the vaccine literally from over a year ago. There's potential signal. And that's why we're doing the database itself. So, in short, if you look at vaccine trends, I'll show you the Excel file by itself. That's kind of what it looks like. As a lot of information that's probably not required per se. And also isolated to the United States with a certain date range. And you'll find that in the GitHub notes as well. So, this is kind of what we have. And what I'll do is have the code posted for you. I may not be able to do it because there's some angle brackets. Maybe I'll be able to do it because I don't have the date range. So I can probably post this code directly on YouTube. And because I don't think I have any angle brackets in there. For those not familiar with angle brackets, especially in regard to something called, there's angle brackets right there. The dates. You see right there? That can allude to something called scripting, which is a hacking technique, and that's why YouTube doesn't like it. So I'll have all this file there. I'll have the links. Again, you download the data. I'll have the links, for example, where the data is. You can use the code exactly as I have it. Just run that kernel, boom. They'll automatically put it into a CSV file for you. You should be able to categorize it, but if you lose your categories, then what you do is you take the data frame dot convert space underscore d types underscore d types, no space, and then you call it. And that should give you some good information. And from there, you can really, really scrape through the data and get an accurate representation of what is actually going on. At the same time, too, get a true appreciation of how sucky the CDC's VAERS data site truly is. And with all the money invested in everything, it's really kind of messy, and I would expect it to see some improvement. There should be no reason that we should have to take vaccine trends from one aspect. There should be no reason we should have to take data files that are all separate. They should all be merged already and easy to extract the information for, which makes it really fast for finding signals in the betterment of public health. Again, links will be there. I'll catch you all next time and hope you enjoy. See you then. Bye.